Hi there, thanks for joining us. Andrew Dunkley here. This is Space Nuts, where we talk astronomy and space science. Thanks for joining us. Coming up on this episode, lots to talk about and really interesting stuff for a change. No, as usual. And this one I saw and thought, gee, we've got to talk about this because we're always looking for something in the outer rim of the solar system. And now we may have found something, and it's not Planet 9. In fact, it's possibly a new dwarf planet, which could mean there is no Planet 9. Interesting. There's a peculiar moon orbiting Saturn known as Iapetus, and it's starting to get attention again. We'll tell you why. And primordial black holes. Yep. And the fact that they might be today's dark matter. Is that a matter we should discuss? Damn right it is, and we'll do it. We'll do it right now on Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And despite his premature enunciation, we officially welcome Professor Fred Walton, astronomer at large. Hello, Fred.
Thank you for that. Yes, I do apologise for being there before I'm there. Forgetting that I have to be formally introduced before I...
It's all good.
Yes, before.
That's how I used to run my radio show. I didn't care what happened. If someone walked in, they were just part of the show. I didn't, I never cared about standing on ceremony or sticking to the rules of radio. What rules? I mean, it's just people talking, isn't it? And playing music and enjoying themselves. I thought that's how I ran it. Even when I worked for the NBC, I was like,
oh, that's right.
I'd been dropped for it a few times, but eventually they saw the light and started going, hang on a minute. For listening to this bloke, we might be onto something. Anyway. They eventually brought in an expert to teach us how to be human beings on the radio.
Oh, really?
Yeah, they did. They did. And when she talked to me, she said, "Don't change a thing," which I think was really a great endorsement after being told to shut up for several years.
Yeah. No, well done. That's good.
Now, before we get started, how's the weather down in Sydney? Because you've been copping a spanking with the rain.
We did, yes. One day last week, just overnight, we had 97 millimetres, or getting on for 4 inches, isn't it, in the measure? Yeah,
that's right.
4 inches. That was just one night. And altogether, we probably had something like 150 over that wet period.
Yeah.
So it was very wet, very miserable, very soggy. Fortunately, everything seemed to hold up. Our downstairs granny flat, which used to flood when it rained, but we had a lot of work done last year. That was in good shape. Everything seemed to be all right.
Yeah. I shouldn't tell you that right now, as we record, there's a big rain band headed your way.
Yes, there is. That's right. We
already know. It's easing off now. We had rain all day, but I'm looking out now, and it stopped raining. The sky's actually thinning. It's still quite grey, but it's moving that way, which is towards you.
Me. It is. We're expecting that later this afternoon. It sort of started off quite bright this morning, but it is definitely looking a bit greyer now. So,
I have some news. At 2:37 a.m. Saturday.
Oh.
Our bedroom door rattled.
Okay.
And my first thought was, that was an earth tremor. And guess what?
It was.
It was a 5 point, well, they keep varying it, but at the time it was a 5.3 earthquake centered around north of Nyngan, which is Nyngan's 160 kilometres west of us, and the earthquake was north of them by about 98 k's. So it was a bit further than 160 kilometres from us. And, it shook because our door doesn't quite latch perfectly. It doesn't hold tight. So it's always a bit loose. So when the air conditioning comes on, it usually goes thump. They said, well, it did more than thump on Saturday morning. It went, and I woke up and went, oh, earthquake. And Judy went, yeah, sure. Really? I said, yeah, I reckon it was, because nothing else happened. Didn't feel any vibration.
Okay, that's interesting. Yeah, you didn't feel it. Just the door did.
Well, we got a great bed. Just very...
That's quite proof.
Paid a lot for it, but yeah, it worked. We didn't feel the earthquake. But yeah, sure enough, next morning I thought I'd check, and Geosciences Australia confirmed it. So a 5.3, which is one of the biggest ever recorded out here. Oh,
yes, that's right. Yeah, it is. So one of my colleagues at the Australian Astronomical Observatory, or former Australian Astronomical Observatory, on the Anglo-Australian Telescope, he is one of the telescope operators, Andre Phillips. He was sitting in the control chair for the telescope, and he felt something as well. He felt the chair being sort of moved as though somebody was shaking it from behind.
Yeah, that's what it feels like, yeah. Because I was in Newcastle earthquake, and I'd done an overnight shift when it hit, and it was 5.5. And it felt to me like somebody just got the end of the bed and was just bouncing it up and down. And yeah, it was much more violent than what we experienced.
It would be, yeah. Actually, Andre, interestingly, this same gentleman I was just talking about, he also runs a very sensitive seismograph at home because he's quite interested in seismometry. So, yes, I think he went home at the end of his night shift, had a look, and sure enough, there was a 5.3 or 5.2 earthquake from Lingen.
Yeah, he would have felt more of it in Coonabarabran than here. Yeah, and I checked the calculation because I looked at the clock immediately, and it was 2:37, and I know that was the exact time because it was an Apple Watch, so it was synchronized.
Yeah,
and I worked out that the vibration took 40 seconds to reach us.
Okay,
at approximately 300 kilometers an hour. Just round figures.
Yes, yeah,
something like that. Yeah. Anyway, give or take, because it wasn't exactly 2:36, but you know what I'm saying. Yeah, so exciting. Haven't been any aftershocks that I'm aware of, but there's a lot of tremors out here that you don't ever feel or notice because they're just so small, but nothing that big. We better get on with it, Fred. And our first story from the cosmos, or closer to home, is a possible new dwarf planet in the extremities of our solar system. This is really exciting if it holds true, and it's sort of stacking up that way.
I think so, yes. This is relatively straightforward astrometry, which is the measurement of celestial objects in space, their actual direction. And it comes from information collected over quite a long period of time with telescopes around the world. So a lot of this discovery is due to archival data, where you can look at images of particular bits of the sky and accurately work out the position of objects in those images. It's actually what you do, Andrew, just as an aside here, when a near-Earth asteroid is detected. The first thing astronomers do is look back through archival data to see if there are any images, photographic images or electronically detected images that will show it, because the longer you can observe something for, the more accurately you can deduce its orbit. And that is true with this object, which turns out to be a TNO, a Trans-Neptunian object. It's been studied by astrophysicists at the Institute for Advanced Study in Princeton, very, very distinguished institution. And what they found is an object with the very unmemorable name of 2017 OF201. It is an object, a Trans-Neptunian object, in a very, very elongated orbit. Its nearest point to the solar system is, I think it's 42 thereabouts astronomical unit. Is that right? No, 44.5. That's its closest point to the sun, what we call the perihelion. 44.5 times that of the Earth's orbit. In other words, 44.5 astronomical units. But the staggering thing is that its aphelion, the furthest point, is, now let me find the number. It's much, much higher. You might have
32?
I think it's more than that. where are we? I think it's in the thousands. It's very, very distant. So when it was found, I beg your pardon, when it was found, it was about 90 astronomical units away. And there are enough observations that it's sort of continuing its orbit. 1,600. Yeah, 1,600 astronomical units. That's its furthest. And that means that it's only going to be visible to Earth-based telescopes for a few % of its orbit when it's at its nearest point to Earth.
They're actually saying, Fred, that it's going far enough out to be entering the Oort cloud.
That's right, part of the inner Oort cloud, which makes it a very interesting object indeed. With an orbital period, if I remember rightly, of 25,000 light years or something ridiculous like that.
25,000 years to complete an orbit.
Sorry, 25,000 years, not 25,000 light years. Yeah, so it's a very, very distant object. In fact, it's probably apart from comets, it's probably one of the most distant objects ever discovered. Because at its nearest, it's roughly the same distance from the sun as Pluto is. But at its furthest, as you've said, it's skimming the inner edge of the Oort cloud, that cloud of icy debris that we recognize as being the source of comets that drift in towards the inner solar system. So a really remarkable set of observations. It's been observed 19 times, so it's got a very high certainty in its orbit. But the quirky part of this, which you've already alluded to, is that when the research team who've done this work actually looked at the simulations of the way the orbit of 2017 OF201 behaves, they found that its orbit is only stable and long-term without Planet 9. So if you have Planet 9 in the equation, then it gets thrown out within 100 million years, which means, that's a short time in astronomical terms. So yeah, it's
if its existence is confirmed, then Planet 9 can't exist. That's what they're saying.
That is what they are saying. Yes, that this is, and a quote from the media, it's one of the strongest pieces of evidence yet against the existence of Planet 9.
Terrible.
Yeah, that's right. It does suggest that there are more objects of the same kind. We haven't found them yet. But yes, the figure I was looking for earlier, it spends only 1% of its time in orbit near enough to be able to be detected from Earth, because it's a relatively small object, thought to be around 700 kilometers, which probably makes it a dwarf planet rather than a large asteroid. And that's imagining that something that size can only be visible for 1% of its orbital period because the rest just takes it too far away. Yeah. It gives you a good idea of just how elongated its orbit is.
Gee, we're lucky to have spotted it given the time frame.
Yeah, that's right, yes, because it'll drift away and will very soon be invisible to our planet.
And it adds a lot of weight to a theory we talked about some time ago from one scientist who said there is no Planet 9. I think there's a whole bunch of stuff out there that's causing the same effect. And this sounds like one of those things.
Yes, that's right. And it's similar. There was a similar argument around the same time by another group of scientists, one of whom I actually spoke to in Canada a couple of years ago, who said effectively that, the evidence for Planet 9 is based on, I don't know, it's probably a dozen or so of these icy asteroids, all of whose elongated orbits sort of line up in the same way. And the suggestion that was being made by these other scientists is that actually it's not so much that, it's a selection effect. We just haven't found all the other ones that aren't aligned in the same way that would, contradict the idea of Planet 9. Yeah. So, yes, this object might be the poster child of the anti-Planet 9 lobby, but it does seem to suggest that it does not, Planet 9 does not exist. And just to to underline what we were saying earlier, it has actually been officially confirmed as an asteroid by the International Astronomical Union. So it will no doubt get a name, because once it's confirmed by the IAU, then you can give it a name. And it's
asteroid or dwarf planet?
As I mean, a name like Pluto or Makemake or one of those names.
But we're calling it a dwarf planet. That's
right. Yeah, at 700 kilometers. I don't think the IAU makes a distinction when they actually confirm its orbit. They don't say anything about its size. Because that's dependent on that depends on measurements that are a lot more difficult to do. But once its orbit's been confirmed, then it becomes an official object, which could be either a dwarf planet or an asteroid.
Okay. All right. So the jury might still be out for a bit, but yes, it's there, and it looks like that's put the kibosh on Planet 9. More to come on that one, I'm sure.
Yes.
Now, if you'd like to read all about it, you can do that at sciencealert.com. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson. Now, let's take a quick break from the show to tell you about our sponsor, Insta360, and their brand spanking new top-of-the-line camera, the Insta360 X5. This is, as Fred would say, a beautiful piece of kit. It's the ultimate 360-degree action camera, and it's designed for everybody, creators, adventurers, professionals, but even amateurs who just want a better job. This is the camera for you. And you can capture the world in 8K resolution. It's got dual sensors. It's got 72 megapixel photos for ultra clear pictures in true to life color. And it's got a very powerful triple AI chip system, which will give you exceptional image quality even in low light conditions. It's got everything. It's also got a pure video mode, so you can just capture everything you want. And what I love about this camera is you don't have to point it at something to get your footage. It will just film 360 degrees, and then you figure out what you want later. It's so seamless, so easy, so simple. I don't think you'd be disappointed at all. And whether or not you're, out on holidays or filming something for a professional finish, you won't have a problem with the X5. It's got incredible durability. It can operate in just about any circumstances, including underwater. If you break a lens, you can replace it. Just pop one out, pop one in. Really quite simple. Up to 185 minutes of battery life. So much going for this beautiful Insta360 X5 camera. And at the moment, as a Space Nuts listener, there's a special deal for you. If you sign up for an Insta360 standard package, and one of the first 30 to do so, you will also get a little bit of a present, an invisible selfie stick. So all you have to do is go to this URL to find out more and sign up for the standard package, the Insta360 X5. And you do that at store.insta360.com. That's store.insta360.com. And don't forget the promo code SpaceNuts. With this special deal going right now on the standard package for the Insta360 X5 camera. That's store.insta360.com and use the promo code SpaceNuts. We've got all the details in our show notes. Now, back to Space Nuts.
0G, and I feel fine.
Space Nuts.
Let's move on to our next story, Fred. I find this one fascinating for one reason. This is going to sound strange. I've never heard of this place.
Oh, really?
Never heard of it. It's a moon of Saturn known as Iapetus. Now, when I say I've never heard of it, when I saw the picture, I went, oh, yeah, I know I've seen that picture before.
Yes.
No, because it's unique. That's why this moon is so very interesting, because questions are still being asked as to how it looks the way it does. It's a strange place, and it's getting a fair bit of attention in social media at the moment. amongst other things. But yes, it's back in the news.
It is back in the news. And I think it is really, as you say, I think it really is social media that stirred this up. Until 2017, when the spacecraft plunged into the atmosphere of Saturn, we were absolutely swamped by marvelous photographs of the moons of Saturn from the Cassini spacecraft. Told us more about the moons of Saturn than we could ever have guessed that we'd learn. And I think, so Iapetus was certainly very much in the headlines then because it is such a peculiar world. But it sort of, because so many of the questions don't really have proper answers, that's allowed it to sort of fade from the attention of planetary scientists. But it's been spotted in the media by social media people who have really raised it once again, as a place of great interest. And maybe that will encourage some of the planetary scientists who've certainly had an interest in Iapetus to go back to some of the Cassini data, maybe using, more modern AI methods to analyze it and actually check out what is going on there. Yeah. So it's the first thing you'd find out about Iapetus, and it was when it was discovered back in the 17th century. Giovanni Cassini, that great observer who discovered the Cassini division, hence the name, made the discovery that this little world orbiting Saturn is peculiar because one side of it was very much darker than the other. Yeah. I remember actually at the start of my career, back in the early 1970s, when I was working at the Nautical Almanac office of the Royal Greenwich Observatory with one of my colleagues there, Andy Sinclair, was a specialist on Iapetus, and he kept telling me it was a very peculiar world. But it was only when Cassini flew by a few decades later that we realized just how peculiar it is. So it is covered in craters, but it's got this dark side, which just looks as though it's been spattered with soot. Looks as though, somebody's put a pile of soot out there and Iapetus has run into it. And you've got this very dark face to it, contrasting with a very highly reflective surface. Now, that's peculiar in itself because it's only on one side, and that's the forward-facing side. Iapetus goes around Saturn tidally locked, so that it always keeps the same face to Saturn. That means there's always a forward side and a backward side. And this stuff's on the forward side. If I'm actually remembering from my talks on Cassini back in the day, I haven't done one of those for nearly a decade. But anyway, that's the one peculiar thing about it. But the other one is even weirder, and this is this equatorial ridge, a ridge that goes all the way around it. It's something like 10 kilometers high or thereabouts. It's a line of mountains, effectively, but it's right along the equator of Iapetus.
It reminds me of a walnut.
It is, that's right. I used to think it looked like a walnut, exactly that. Yeah. And so, there's various theories as to how it got there. And the one that I thought was the most common one was that it was caused by the contraction of the crust of Iapetus.
That makes sense.
That if as Iapetus cooled after its creation, it's rotating on its axis, the crust contracts until you get a bulge which naturally forms around the equator of rotation, right angles to the axis of rotation. But I think other hypotheses have been put forward. One is that perhaps there was a ring system around Iapetus that actually collapsed and fell onto the surface and generated the ring of mountains. Another one is possibly icy material coming out from beneath the surface of Iapetus. We know that many of the moons of those outer planets have got ice or perhaps icy slush underneath the surface. because of the fact that they're what we call ice worlds with a central rocky core, a liquid ocean above it, which may be quite slushy, and then a crust of solid ice on top of that. That could be the construction. Once again, if you've got stuff coming up from beneath the surface and the object is spinning fast enough, then you will get perhaps a ring of mountains like we see on Iapetus, none of which come from the original idea, which was contraction. So I'm very interested to know where the scientific, consensus is going on this little world, and it's great that it's cropped up again. It's welled up again into the public consciousness.
It has. Yeah, and another theory I read was just a high spin rate at some stage.
Yes, yeah.
That would cause a bulge rather than a mountain range. I would expect that.
Normally that causes a planet to flatten slightly, so that it's a bulge. It's the Earth's shape is that what we call an oblate spheroid. Saturn itself actually is the most extreme example in the solar system because it's the diameter between the poles is significantly less than the diameter across the equator. It's this kind of oval shape in cross section. So that's what you'd expect from something rotating quickly, not as a well-defined ridge of mountains like we see on Iapetus. Quite an amazing world.
Another weird factor, I suppose, is its proximity to Saturn. It's actually a long way away.
Very far, yes, that's right. It's, 3.2 million kilometers or thereabouts? It's a long, long way. 3.22 million kilometers from Saturn.
Could the dark face be some sort of reaction with Saturn, radiation or something like that?
It's the thinking back in the Cassini era, and I suspect it's probably similar, is that it consists of organic chemicals that form this kind of soot. I think solens might have been invoked as well. These are particular organic chemicals that we know coat a lot of the outer worlds because they're generated by, I think, the impact of cosmic rays on material. But it's the peculiar thing is that it's only on one side. It looks as though it's just kind of run into something that's splattered all over the front of it.
It's got that impression. Yeah, somebody spilt the paint.
Just what it looks like. That's right.
Really odd. Yeah, if you'd like to take a look at it, Iapetus is all over the internet, lots of social media, but there's a great article at dailygalaxy.com worth reading on Iapetus. It starts with an I. It's spelled Iapetus, Iapetus. This is Space Nuts with Andrew Dunkley and Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Our final story today, Fred, takes us to the very rare area of black hole discussion. We get so many questions on this. I mean, it's unbelievable. In fact, I think there was a question popping up about black holes in our next episode, as a matter of fact. But and I think the reason is quite simple. People just want to understand them, and there's so much we don't know. This particular story focuses on primordial black holes and the possibility that they may well be responsible for today's dark matter. Please explain.
Well, yeah, this is a piece of theoretical research, which is good because you need it. This is research by Japanese scientists in Tokyo and elsewhere. And what you have got here is people who are looking sort of almost with new eyes, if I can put it that way, at the dark matter problem. Because dark matter is a big problem. We've got this stuff that seems to have a gravitational hold on galaxies so that they don't fly apart, and a gravitational hold on galaxy clusters so they don't fly apart as well. And yet we can't detect it. We cannot detect it in any way other than by its gravitational pull.
Yeah, we've never captured any of it or anything like that.
No, that's right. So there's what have we got to go on? not very much in terms of our understanding. However, there was quite early on in the dark matter story a number of experiments carried out on big telescopes. One of which was actually here in Australia, a very historic telescope called the 50-inch at Mount Stromlo, previously known as the Great Melbourne Telescope, because it was very old, but it had been modernized with new equipment. And they did an experiment which was called MACHO, and it was designed to look for the gravitational lensing effect of large objects in the universe, basically, in the vicinity of our galaxy. And by large objects, I mean things that aren't subatomic particles. So I mean things like orphan planets, dead stars, or black holes. MACHO was actually an acronym for Massive Compact Halo Objects. Now, they didn't see as many of these gravitational lensing phenomena, in other words, the space around one of these objects being bent so it magnifies an object behind it. Yeah. They didn't see any in numbers that were sufficient to make MACHOs the missing dark matter. And so that was in the 90s. That really ruled out things like black holes as being the culprits for dark matter. And so that's when we were, our attention was shifted to the idea that dark matter is actually some species of subatomic particles, perhaps many species, but ones that don't interact in any way with normal matter. And that's where things remain today. So it's interesting to find a paper which kind of goes back to an older idea that maybe black holes actually do contribute to the dark matter. And the reason why I think this paper has been published is that there is a slightly new twist to it, because these are, the postulate is that these are primordial black holes which were created at the same time as the universe was. In other words, during or immediately after the Big Bang. So that you basically find these objects potentially. We've never observed a primordial black hole. People just kind of guess that they are there, and we do see black holes that maybe fall within the mass range of a primordial black hole, but we don't actually know that they exist. But to come to the point, I'm not being very clear here. What has actually led to this research is that the lifetime of a black hole is possibly much, much longer than Hawking predicted that these primordial black holes would last. He gave them, because they were smaller, he gave them a relatively short lifetime. Black holes, we know, do evaporate because they release Hawking radiation, this quantum mechanics phenomena. And the idea, even though that is a very, very slow process, if you've got these sort of mini black holes that were formed in the origin of the universe, our thinking was that they might all have evaporated by now. And that's where this new research comes in, because they're proposing a new mechanism, which has got an interesting name. It is something called, I've lost the name of it. It's basically, the memory burden effect. Work that one out.
Yeah.
The memory burden effect suggests that the information stored, if I can put it that way, in the black hole actually stabilizes it and keeps it from decaying. So that to cut to the quick, the idea is that these primordial black holes might last a lot longer than Hawking predicted they would, and perhaps they are, after all, the missing dark matter. Now, that still has to account for why we didn't detect them by gravitational lensing during the MACHO experiment and similar experiments carried out elsewhere in the world. But it is an interesting possibility.
Yes. It's probably the best theory we've got, I suppose, at the moment.
Yeah, I'm not sure that it is.
Oh, okay.
I think, because we don't even know whether primordial black holes actually exist, we don't know that these subatomic particles exist either. But it seems to me that the bill is better fitted by what black holes might be, by what dark matter might be, by the subatomic particles rather than primordial black holes.
Well, they won't be letting you do a peer review, will they?
They won't. No, that's what I mean. I've made my mind up already, you see. Well, we don't know what they are. What are they neutralinos? Are they WIMPs, weakly interacting massive particles? Sterile neutrinos? There's all kinds of things that have been proposed for these subatomic particles, but none have yet been detected.
Yeah. All right. Interesting. I'm sure that'll spawn no questions whatsoever from our audience.
Heidi will have to deal with them next time.
Yes, she will. Yes, she will. Indeed. So if you'd like to chase that up, there's a great article on phys.org, phys.org, detecting the primordial black holes that could be today's dark matter. Fred thinks not. But that's what science is about, tossing these ideas around. And that brings us to the end of yet another episode of Space Nuts. Thanks, Fred.
It's a pleasure, Andrew. Always good to talk, and I look forward to our next time.
Indeed. And thanks to Hugh in the studio, who couldn't be with us today. He found himself a primordial black hole, and we've not seen him since. Apparently, loves spaghetti. From me, Andrew Dunkley, thanks for your company. Catch you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.